Hello friends, this is the tutorial video for the Excel program that I have made in shear reinforcement design for reinforced concrete. So shear reinforcement are designed to withstand shear, or also called as the diagonal stress in which the structure is subjected. It is in a form of stirrups which have different types as well. So let's dive into it. So this figure shows that the Vmax is located at the outermost span of the beam from the center line. The next is the VU, the VVC over 2, the center line. And this D right here is the depth of the beam. The Vmax and the VU between them are where the splitting or the true shear failure is located. The National Structural Code of the Philippines have two classifications. It has 2001 and 2010/2015 NSCP code. Each code has slight difference from the other. Example is this reduction factor, the formula in calculating VC, and this right here. So if we want to calculate design using 2010/2015 NSCP code, we just have to choose in this right here in this portion. So let's have an example to show the effectivity of this Excel program. So we have the base. We can see in the figure we have a base of 350, the height of 650, the effective depth of 562.5, and it is evident in the figure that it is two-legged. The concrete strength, which is 28, yield strength of 276, girder span of 7.2, and since FC is less than is 28, then we can use 10 mm diameter bars. The dead load given is 36 kilonewton per meter. The live load is 54, and it calculates the value of the WU, or the uniform load, which is 142.2, and we can see that the area of the stirrups is 157 mm squared, is greater than the AV minimum required, so the assumed value is acceptable. So in this part we can the VU is calculated using this formula, and so on and so forth. And since VVC is less than VU, hence stirrups are needed. And using this formula, 0.66 square root of FC prime base times the depth, for 2001 NSCP code, we have the value of 687, which is evidently greater than the VS. So remarks, okay, we can now proceed to the design of the beam. The spacing of the stirrups is calculated using this formula, AV times the Fy times the depth over Vs. We have the value given this data, 72 mm. Rounding it to the nearest tens, we have 70. And since Vs is less than 2 Vc, we can use this D over 2 as, or 600 mm. So using the lesser, so we have the S max 281.25. So the location of the first stirrup is calculated using 0.85 times the spacing of the stirrups. So we have 17.5 mm from the face of the support. So here, this is the design table. So this table is the design for the stirrups. So at 0.5625 meters, the video is 41.933 VSS, and we assume a lesser value than the S calculated for safety, and we have 50 of 8 pieces at 1 meter. We have 369 VU, VS 261, and S 93. So we can observe that as the beam is getting farther and further from the face of the support, the VU and the VS that the beam experiences is getting lower as well. So I stopped in this portion because from here 2.5, from 2.5 up to the end of the beam, we can say that it is safe to use 250 mm as long as it is lesser than 281.25. So if we want to design using 2010/2015 NSCP code, all we have to do is click the drop down list right here. So that's all. Thank you.